This video is going to walk us through using the point-slope form of a line. We are going to graph linear equations given the information in the point-slope form, and we're going to write equations of lines using the point-slope, and we're also going to talk about the relationship between parallel and perpendicular lines, and writing equations to find equations that are parallel and perpendicular to other lines. So let me start by introducing the point-slope equation of a line. And this is going to be y minus y1 equals m times x minus x1. This is the point-slope form of a line. And the reason it's called the point-slope form is because it tells us a point, and that's our x1, y1. And it also tells us the slope, which is our m. So if we're given that information, both a point and a slope, we can easily write the equation of a line. So for example, if we're given that m, let me change that size a little bit right there. If we're given that m is our slope and it is equal to -3/4, and that we have the point passes through the point 2,5, then that's going to be our x1, y1. Then we can simply plug those values into the point-slope form and write the equation of the line. So y minus 2 is equal to, so that's our y1, m, which is -3/4, times x minus 5. And then we can clean it up if we want to and change it even to the slope-intercept form by distributing the -3/4. And that's going to be 15/4. And then we could add 2 to both sides if we wanted to. And we would end up, after we found the common denominator and added 15/4 and 2, we would end up with 23/4. 8 was the common denominator, so 23/4. So that's one thing we can do with this point-slope form. The other thing we can do is we can actually graph the line. So with this, we are going to start at our point, and then we're going to apply the slope to find additional points. So we're going to first graph the point 2, 5. So we're going to go to 2 on the x and then 5 on the y, which will be this point right here. And then we're going to apply the slope, which is going to have us rise -3 and run 4. So we're going to go down 3 and over 4 from that 2, which is going to put us out here at the 6, which I don't even have marked off, but I can add that hash on there. And then we have our 2 points that define the line, and that is our line. So graphing using the points and the slope, given that information. Let's take a look at another one. So let's say we were given that we had a slope of -1/2 and passing through the point 2, 3. So let's graph this one first. Those are not very equally spaced, but you'll get the idea, right? Okay, so we're going to start at the point 2, 3. So over 2, up 3. That's 1 point on our graph. The -1/2 means we're going to go down 1 and over 2. We could do it again too if we wanted just to continue that. And I'm going to actually use my little ruler tool this time. And we are going to draw our line in. And then this is our nice line right there. We could also go from there and find the equation of the line. Once again, we're going to take those values and plug them into the y minus y1 equals m times x minus x1. So plugging those in, we get y minus 3 equals -1/2 times x minus 2. And once again, we could put that in the slope-intercept form if we needed to. Distributing the -1/2, I'd have -1/2 x plus 1. And then I can add a 3 to both sides to isolate that y. And I get y is equal to -1/2 x plus 4. Now let's say that we were given 2 points and we wanted to find the equation of the line. So in using the point slope form, we need to have a point, obviously, that's why it's called the point slope form. But the other thing we need to have is the slope. And as I'm sure you're aware, the equation for the slope is y2 minus y1 over x2 minus x1. And this is actually just a derivation of the point slope form. So change in y over change in x. So given any 2 points, we can find our slope. So if we're given these 2 points, then this is going to be our x1, y1, and this is going to be our x2, y2. And we're going to plug those values into the equation, into the formula for the slope, and we get -2 minus 2 over 4 minus -1. Keep in mind that those first 2 terms, the x2 and the y2, should come from the same point, and the x1 and y1 should come from the same point. It's just a little checkpoint for you. And then we can subtract these by doing keep, change, change. So -2 plus -2 is -4. And then if we keep, change, change here, we get a 5. So our slope of that line is -4/5. We can then take that slope in one of the points, and it doesn't matter which one, and plug it into our point slope form. So y minus 2 is equal to -4/5 times x minus -1, which becomes plus. And if you were asked to just leave it in that form, you could leave it there, or as we've done before, you can change it to the slope-intercept form. So the whole point about the point slope form is you must know the slope and you must know a point. And one way to find the slope is if you're given 2 points, or in our previous examples we were actually given the slope. All right, I want to take a minute and talk about the relationship between parallel and perpendicular lines. So if you have parallel lines, if you think about it, it kind of makes sense that the rise and the run on parallel lines is going to be the same. So parallel lines have equal slopes. Perpendicular lines are lines that form a 90-degree angle. And perpendicular lines have negative, move that, so let me write here, negative reciprocal slopes. So what it means by negative reciprocal is that they have opposite signs, and the reciprocal means that they are flipped. So for example, if you had a slope of 2/3, then the perpendicular slope would be -3/2. If you had a slope of 5, the perpendicular slope would be -1/5. So flip it and change the sign. One more example is if you had a slope of -1/2, then the negative reciprocal, the perpendicular slope, would be 2. So let's consider this setup. Let's say that we wanted to find the equation of the line that passes through the point 2, 3 and is parallel, that's the symbol for parallel, to the line 5x plus 3y is equal to 1. Now keep in mind what I said earlier. What I said earlier is we can use the point slope form to write the equation of a line. and we need to know a point, which we have right here, and we need to know a slope. Well, we're not really given directly the slope, but we're given a path to find the slope. This equation is parallel to the equation we're looking for. So if we find the slope of this line, then that's the slope of the line we're looking for. In this form, it's hard to see the slope, but if we change it to the slope-intercept form and solve for y, then we can find the slope of that line. So I'm going to subtract 5x from both sides, and then divide through by 3, and we get y is equal to negative 5/3 x plus 1/3. Now it's really important for me to emphasize to you that the only number we care about from this equation is the slope. So many times people want to jump in and use this number, but that number is not necessarily related to the equation we're looking for. The only way our two equations are connected is that they're parallel, which means they have the same slope. So now I have the slope for the line I'm looking for, negative 5/3. And I have my point. So I have my two pieces of information I need to write the equation of this line. So I'm going to do my y minus y1, so y minus 3 is equal to negative 5/3 times x minus 2. And that is the equation of the line. And you can change it to whatever form you need to put it in from that point. Let's take a look at another one. Let's say that we were given that we wanted to find the equation of a line that passes through the point 2, 3. And we're going to use that same equation there and is perpendicular, and that's the symbol for perpendicular, to that line 5x plus 3y is equal to 1. Now luckily we've already solved that for y, and we know that the slope of this line is negative 5/3. So the perpendicular slope is going to be the negative reciprocal. So that's going to be 3/5. So the slope of the line I'm looking for is 3/5. So we need to know a point and the slope. We have both of them. And we can plug that into our y minus y1. So we have y minus 3 is equal to the slope, which in this case is 3/5, times x minus 2. And that is the equation of the line that passes through the point 2, 3 and is perpendicular to the equation 5x plus 3y equals 1. Thank you for watching. If you've never watched one of my videos before, subscribe to my channel. If you want me to make a special video for you, put it in the comments and I'll make a video just for you. Thank you.